Forget everything you thought you knew about traditional farming and its limitations. The biggest misconception about sustainable agriculture is that it's going to be as productive or profitable as conventional methods. But the future of food production isn't about compromise. It's about intelligent integration. We're going to show you how a seemingly simple system is radically transforming resource use and crop output, proving sustainability can actually lead to superior results. Welcome back to the channel. Today, we are stepping inside the high-tech world of modern agriculture, but we are not talking about drones or self-driving tractors. We're talking about something you probably have in your own home, but on a massive intelligent scale: HVAC. That's right. Heating, ventilation, and air conditioning. It sounds almost mundane, but in the context of controlled environment agriculture, or CEA, Smart HVAC is the unsung hero, the silent conductor of an orchestra that produces healthier, more abundant crops while protecting our planet. So, what exactly is a smart HVAC system in a farm setting? It's far more than just a giant air conditioner. Think of it as the central nervous system for a greenhouse or an indoor farm. It's a network of sensors, automated controls, and advanced software all working together to create the absolute perfect microclimate for whatever is being grown. It doesn't just cool or heat the air. It meticulously manages temperature, humidity, CO2 levels, and air circulation with surgical precision, 24/7. Let's break down why this is such a game changer. First, let's talk about precision. Traditional farming is a battle against the elements. A sudden frost, a heat wave, a drought, these can wipe out an entire season's crop. Greenhouses offered a basic level of protection, but they were still largely passive. A smart HVAC system changes the game entirely. It creates a perfect, consistent Goldilocks zone for plants. Whether you're regrowing delicate leafy greens in the Arizona desert or juicy tomatoes in the dead of a Canadian winter, the system ensures the plants experience their ideal weather every single day. This level of control eliminates the weather-related risks that have plagued farmers for millennia. This precision leads directly to our next point: higher yields and better quality. When a plant isn't stressed by being too hot, too cold, too dry, or too humid, it can focus all its energy on what it does best: growing. With optimal CO2 levels for photosynthesis and ideal temperatures for metabolic processes, plants grow faster, stronger, and produce more. We're seeing indoor farms that can harvest crops multiple times a year, sometimes over 10 times more than a traditional field of the same size. And it's not just about quantity. The quality is often superior too. The controlled environment leads to more consistent flavor, texture, and nutritional value. The produce is cleaner, often grown without the need for pesticides, because the enclosed system keeps pests out. Now, let's get to the sustainable part of sustainable agriculture. This is where Smart HVAC truly shines. It might seem counterintuitive. How can a massive climate control system be good for the environment? The answer is efficiency. These aren't your grandpa's window units. Smart HVAC systems are designed for maximum energy efficiency. They use variable speed fans, predictive algorithms that anticipate weather changes, and even integrate with renewable energy sources like solar panels. They can recycle heat generated by lighting systems and use it to warm the space at night. This intelligent energy management drastically reduces the carbon footprint compared to older, less sophisticated climate controls. But the biggest sustainability win is water conservation. Agriculture is one of the world's largest consumers of fresh water. Traditional irrigation is notoriously inefficient, with much of the water lost to evaporation or runoff. In a closed-loop system managed by a smart HVAC, it's a completely different story. The system carefully controls humidity. The moisture that plants release through a process called transpiration is unjust vented into the atmosphere and lost. Instead, it's captured, dehumidified, and recycled right back into the irrigation system. We're talking about water savings of up to 95% compared to traditional field farming. Imagine growing pounds of lettuce with just a single gallon of water. That's the power we're talking about. Furthermore, by enabling urban and local farming, these systems cut down on food miles. The average meal in the United States travels about 1,500 miles from farm to plate. That's a huge amount of fuel, emissions, and potential for spoilage, vertical farms, and high-tech greenhouses can be built right in or near cities, slashing transportation costs and emissions. Food is harvested and can be on a store shelf or in a restaurant kitchen within hours, not days. This means fresher, more nutritious food for consumers, and significantly less waste. It's estimated that up to 40% of food is wasted in the supply chain, and reducing transit time is a massive step in solving that problem. Let's look at a real-world example. Take a company like Plenty or Aero. These are vertical farms, growing towers of produce indoors under LED lights. Their entire operation hinges on the precision of their environmental controls. The HVAC system isn't just an add-on. It's integral to the design. It works in concert with the lighting to manage heat, with the irrigation system to manage humidity, and with CO2 injectors to maximize photosynthesis. The result is an incredibly productive and sustainable model. They're growing food year-round, in the middle of urban centers, using a fraction of the land and water. This isn't science fiction. This is happening right now. So, what are the challenges? Cost is the big one. The initial investment for a sophisticated smart HVAC system is significant. This can be a barrier for smaller farms or startups. However, the return on investment is compelling. The savings on energy and water, coupled with the increased yield and premium price for high-quality, local produce, means these systems often pay for themselves much faster than you'd think. As the technology becomes more widespread, we can expect costs to come down, making it accessible to a broader range of agricultural businesses. Another challenge is the expertise required to design, install, and manage these complex systems. It's a fusion of agricultural science and engineering. Looking to the future, the integration of artificial intelligence and machine learning is making these systems even smarter. Imagine an HVAC system that learns the specific needs of a new crop variety over time, automatically adjusting parameters for even better results. It could analyze data from thousands of sensors, predict potential issues like mold growth before they happen, and even adjust its own energy consumption based on real-time electricity pricing. This is the next frontier, a truly autonomous, self-optimizing farm environment. In conclusion, the humble HVAC system, when infused with modern technology, becomes a powerful engine for a new era of agriculture. It's the key to decoupling food production from climate and geography. It allows us to grow more with less land, less water, less energy, and less waste. It empowers us to build a more resilient, secure, and sustainable food system, bringing fresh, healthy food closer to our communities. It's not just about air conditioning. It's about fundamentally reimagining our relationship with food and the planet. The quiet hum of these intelligent systems is the sound of a greener, more abundant future being built, one perfectly controlled cubic foot at a time. Thanks for watching. If you found this look into the future of farming fascinating, make sure to hit that like button and subscribe for more deep dives into the technologies shaping our world. Let us know in the comments what you think about smart HVAC in agriculture. See you in the next one.